Hello everyone. Today we're going to talk about equivalent algebraic expressions with like terms. Today in this video we're going to take a look at equivalent expressions that represent the same situation. And we're going to talk about how equivalent expressions can be made by combining and separating like terms. Now, if that is all confusing for you, don't worry about it so much. Let's look at some examples so that this makes sense. Before we actually look at some examples, let's take a look at what like terms are. Like terms are something that you're going to be hearing about quite a bit as you get through middle school and into high school. So it's really good to know what that means, what like terms means. Now, like terms are terms that have the same variables and the same powers. Okay, now let's take a look at what variables are. Okay, so variables look like letters such as A, B, and C, and variables are letters that stand or represent usually unknown numbers. Okay, so like for example, we don't know what A is until somebody tells us what A is. We don't know what B is until somebody tells us what B is. Okay, that's why variables are unknown numbers. Okay, and speaking of variables, right now as of late, Pokemon cards, they're at McDonald's, and basically, you don't know what's inside these Pokemon packs of cards until you open them. So variables reminds me of unopened Pokemon cards because we don't know what it is. Okay, and so variables are unknown numbers. The next thing we want to talk about are powers. What are powers? Now, these are examples of powers because this is 3 to the 8th power and this is x to the 2nd power. Now, keeping in mind that one way to remember what powers are is if we remember this example on the left of Tommy Smith and John Carlos. They put their fists in the air, and many people have called this the Black Power salute, and it happened during the 1968 Olympics. So when we think of power, put your fists in the air, and that'll remind you of power. Okay, why? Well, look at this. Okay, powers are the exponents in the air, just like the fists in the air. Okay, so these exponents right here are in the air. The 8's in the air, the 2's in the air. Those are powers. Okay, and powers are also repeated multiplication, and repeated multiplication is also very powerful. Okay, so do this when you're trying to remember what powers are. Power. Okay, now let's try to better understand what like terms are. Now, like terms are terms that have the same variables and powers. So like for example, let's take a look at 4 groups of x squared and 1 group of x squared. Now, are these two like terms? Well, let's take a look. Do they have the same variables? Yes, they both have x's. Do they have the same powers? Yes, this is to the power of 2 and this is to the power of 2. And because of that, these two are like terms. We also know that 3 groups of x and 8 groups of x are also like terms because they have the same variable of x and the powers. Hey, this one doesn't have a power, it looks like, and this one doesn't have a power, it looks like. But actually, hey, there's only one x. So actually, the power is actually 1, even though we don't really see it. Okay, now another thing to think about here is these are also like terms. Okay, why? Well, do they have any variables? There are no variables. Okay, do they have any powers? We don't see any powers. But however, because they both don't have variables and because they both don't have powers, they are still like terms. And just like for these right here, 3y, 3 groups of y, and sorry, different color, 3 groups of y and 7 groups of y, they're also like terms. Okay, now while we're thinking about this, I also want you to think about this. Why does 4 groups of x squared and 8 groups of x, why are they not like terms? Why are they not like terms? So try to think about that one. All right, we have this awesome expression here right on top. And one thing that a lot of people like to do in algebra is to try to figure out another way to write this expression. So we want to know what this expression can also equal to, okay? Now, one way to understand this is by using algebra tiles to represent this expression. So let me do that for you right now. So here we want 2 times n, or 2 groups of n. Here we go. And then I want 3 groups of n squareds, or I want 3 times n squared. So here's 1, 2, and 3. And now I want 4 groups of n. So 1, 2, 3, and 4. And I want 3 ones. So 1, 2, and 3. Okay? Now, here's the thing. We just talked about combining like terms. Okay? So putting together terms that have the same variable and the same power. Okay? So for example, I could take these 2 n's and combine them with these 4 n's, and I can put them together, and now I have, how many n's do I have? I have 6 of these n's. 6 groups of n. Plus, what else do I have? I still have the 3 groups of n squareds, or 3 groups of n to the 2nd power, plus the 3. Okay? Guess what? We just came up with equivalent expressions. These are 2 expressions that are equal or equivalent to each other. I have one more expression for you. 8 times x, or 8 groups of x plus 6 equals what? And so I already did the algebra tiles for you. So how could we write another expression that's still the same as this? Okay, well, one idea might be, well, we can separate any number of these. So let me just separate these. Okay, so I just separated the 3 groups of x right here. I'm keeping the 6 the same, but I have 5 groups of x right here. And it looks like that. 3 groups of x plus 5 groups of x plus 6. Okay? Again, these are 2 expressions that are equivalent to each other. And I can keep on going, and I can keep on coming up with different expressions. This is not the only expression that could work. Okay? In fact, there are so many different expressions that could possibly work. All right, everybody, that is it for this video. Take care and have a great day.